batteries, and also in
I think there is an error or disconnection from Dr. Elias. Hi, good afternoon. I think there is a disconnection from Dr. Elias' laptop, so let us wait him to fix that error. Yes.
Okay, sorry, I am back again. I was kicked out from the meeting. As I said, so we're going to have a very rich program of activities for the whole academic year 2021-22, and hopefully every one of us is going to benefit. So our first presenter today is Mr. Mohammed Rehan. He's a research assistant at the Radio Astronomy Laboratory. He has a great experience in terms of observing in the radio band. And as usual, today is going to talk about the ozone layer, or what you call the depletion of the ozone layer, and what are the problems that are generated by what we do as activities on Earth. So I would like to ask Mohammed Rehan to take stage, and we thank him in advance for his presentation. If there are any questions, I would like to ask you to leave it at the end of the presentation. And I thank you for your cooperation. So please, Rehan.
Thank you, Professor Elias. Good afternoon, everyone. I'm Mohammed Rehan from Radio Astronomy Lab, and today I will this talk will be as a celebration of the International Day of the Preservation the ozone layer. Our talk will be about the depletion of ozone layer. You know that the ozone layer is one of the important layers on our atmosphere. Yes. There is a point to discussion. We can discuss it at the end of this lecture. About the relationship between the ozone layer depletion and the global warming. So the global warming or ozone layer depletion, it is not or doesn't mean the global warming, but there is some effect of the ozone depletion layer on the global warming, as we will discuss later on, inshallah. Now I will start with the atmosphere layers. The scientists for decades divided the atmosphere for several layers, starting from the Earth's surface. Okay, so the first layer stretched from the Earth's surface to a few kilometers. It is a troposphere. It's called the troposphere because has a turbulence and all weather condition included in this layer. So troposphere, stratosphere, mesosphere, thermosphere, and exosphere. Where is the ozone? We will see where the ozone layer among these layers. So I will start with the troposphere. The troposphere starts, as I mentioned, from the Earth's surface and extended to 8 to 14 kilometers. It depends on your latitude. So on the tropical area, it extends to, on average, to 14 kilometers height, but in the polar areas, It is only from 7 to 9, on average 8 kilometers thickness. So the part of the, it is this part of the atmosphere because the gravity compresses the air down. And almost the all-weather condition, all our climate, the cyclones, the rain, clouds, everything is happen in this layer, the troposphere. The second one is the stratosphere. So it is just above the troposphere, and between them there is a sublayer. It's called the tropopause. So it's extended to 50 kilometers, 50 kilometers above the previous one. So in this layer, there is a sublayer. It's called the ozone layer. So which is which it is responsible to absorb and scattering the UV or ultraviolet ray comes from the sun. The mesosphere starts just above the troposphere and extend to 85 kilometers. All meteors or most meteors burn in this layer. And also we have a thermosphere. The thermosphere starts just above the mesosphere and extends to 600 kilometers. It is the ISS rotates, or not flight. It rotates around the globe in this layer, the thermosphere. So it is not let's say it is not ideal vacuum in that high. And the ionosphere, we know the ionosphere, it is a dynamic layer, and it composed or consists of ions, electrons, molecules, charged molecules. So this layer is stretched from 48 kilometer above the surface of the edge. So the ionosphere, we can say the ionosphere, it is the beginning of the real space, or the space as we know. The exosphere, it is anything outside the Earth atmosphere. So let's see the when we see this video or this animation, we can see why scientists divided the atmosphere for these several layers. Why they didn't represent the atmosphere or classify the atmospheric layers as one or two layers. The answer is the temperature dominates the classifying the atmospheric layers. So the temperature, it is the main factor that can let's say separate or make layers and barriers between layer and one layer and the upper one. So look to the flask here. When you put, I will play it again. Yes. Yeah. Look at this. There is some drops of ink or color at the bottom of this flask. When they put a candle under this flask, the temperature make or heat the color, the drops of color, and make some turbulence as we see here. So the temperature, it is the main player on this equation. So if you look to the chart here on the left side, you can see the tropopause, the troposphere. When you go up among the troposphere, the temperature will drop. Okay, until the tropopause. Tropopause, it is a sublayer or the barrier between troposphere and stratosphere. the stratosphere, in the contrary of troposphere, the stratosphere starts to work in the opposite behavior. Like when you go up through the stratosphere, the temperature will be higher. That means the stratosphere, it is very, very stable in terms of thermodynamics or the thermodynamics properties of the air masses. So in the stratosphere like this, and when we reach to the mesosphere, the same thing as a troposphere, and again with the thermosphere. So this zigzag shape of the temperature relationship between the height or temperature versus height plotting, this what tell the scientists to divide the atmosphere for these layers. So the ozone layer should be here, just above the mesosphere. There is an important phenomena. It's called the thermal inversion. So the thermal inversion, when you heat the surface air, or the air mass that's very, very close to the air surface, when you heat it, it become less dense, and then it will start lifting up. So if you in any height have an air mass has a more or warmer than the rising air mass, there is it looks like a barrier or the roof of the air. So the air mass will start rising, and when it reaches to the layer that has a higher temperature, it will stop and it will form the stratus layer or one layer and very, very unique layer above the troposphere. So, for example, if you look to the cities, look at the picture on the right side. The hot and polluted air mass near to the earth, to the earth above the city's building. Okay, when this in the normal. In case of we don't have or without the thermal inversion, like the right picture, the air mass will rising up and continue rising and so on. So the polluted air will spread away and it will go. But if you have thermal inversion layer above the city, in general, above the cities, the warm polluted air will stop on the certain height and form this layer as we see in this picture for one of the cities. I think this is Los Angeles, or no, that's not Los Angeles. I don't know. There is a beautiful mountains behind, but you can see the dirty air mass above the city. Now, let's talk about the ozone. So the ozone, it is just above the troposphere, as we said. It is the beginning of the stratosphere layer. So the ozone layer, it's composed of oxygen, but it is not normal oxygen. There is a normal oxygen, and there is a considerable amount of one of the important molecules. It is not stable in the Earth or on the atmospheric normal pressure, like the air surface or the sea level air pressure. It's called the O3. So some bonds, chemical bonds, form this molecule here because of the when the UV strike the O2, it breaks the bonds, the chemical bonds, and make two atoms or three atoms, and another one. When these atoms face any other molecule O2, because there is a lot, or there is a shower of UV ray on this height, and the pressure is very low. So the compound, it's called, or a molecule, it's called the ozone, or O3, formed by this process. So the UV, the UV produce or build ozone layer, and then ozone layer blocks the UV and prevent it to reach to the Earth's surface, like the melanin, the melanin chemical. It's a chemical material in our skins. When you go to the sea, or when you expose yourself to the sun, so the melanin layer will form, and it will protect your skin from the UV after that. So the same, you can see the same mechanism happened in the ozone layer. Now let's talk about the enemies of the ozone layer. So the ozone layer, as we said, it blocks, partially blocks the UV, and high energy UV photons come from the sun. But there are a lot of enemies. These enemies produced by our civilization, by our machines and refrigerators and air conditions and every man-made instrument, or some of the man-made instrument. This blacklist, it is hard to pronounce these chemical material or chemical compounds, chlorofluorocarbons, CFCs, and carbon tetrachloride. Yes, it is a CCl4. It is very famous one, by the way. Methyl chloroform, and so on. So this list, most of them consist chlor or brome or fluor. All of these elements are harmful. We know this. This is it's called the halogens elements. So they are very active. They're poisonous. It is dangerous. But when they compound with the carbon, like CCl4, a very strong chemical compound will be produced. So it is not easy to break these bonds and keep the free chlor or free carbon, and then the chlor will be threat our health. So it will not be in this condition, in the earth or sea level, let's say sea level, normal pressure and temperature and so on. But the problem will be where these elements are very stable, as we said. It is not poisonous, by the way. The compound, not the chlor. This compound, this material, and because of it is very stable, it can last and accumulate in the atmosphere for 100 years. So it is very dangerous. It looks like a plastic. Our problem with plastic is it is not poisonous, but it will. It is not easy to decay on the soil. So if you put a bottle of plastic, maybe it will last. Some of them claims it will last 1,000 years. So the same problem with these chemicals. But why? Why these chemicals? Okay, let us assume these chemicals that used in the AC machines. If we have a lot of fluorocarbon or anything of these chemicals in the atmosphere, it is not poisonous. So where is the problem? The problem is when these compounds accumulate on the same altitude of the ozone layer, they will take as you see in this animation, they break the bonds of the ozone, the O3, that, as we said, that protect ourselves from the UV high energy photons, and make a new chemical bonds with the free oxygen atom. By repeating this process and in the very large scale, the phenomena, the result phenomena will be decaying and depletion of the ozone layer year after year. So the more chlorocarbons we produced, the more depletion of the ozone layer. So that was a very massive problem, environmental problem, as well as the global warming. But it has a different reason. The global warming happens because of increasing some gases like methane and water vapor and the CO2. Yes, but this one, it is it looks like attacked the ozone layer by these molecules. So this is a very dangerous and harmful effect. Let's see again. There is three types of UV ray comes from the sun: UVA, UVB, UVC. So the harmful one is UVC. It is more energetic. So the ozone, stratospheric ozone, protect us from this harmful UV ray. So when the ozone layer has removed, the more UVC type ray will reach to the Earth surface, and it will be very harmful for the life in general, by the way, not only for the human being. So it's called the stratospheric ozone. There is another ozone on the near to the Earth surface, but it has a minor effect, unlike the stratospheric ozone. The ozone, or it's called the tropospheric ozone. The tropospheric ozone cause it is harmful. It is not desirable like stratospheric ozone. So the ozone, by the way, it is poisonous. It is harmful for the human organs, because it kills the cells. By the way, a lot of vaccination or air vaccination machines use the ozone or water also. Vaccination, the water use the ozone gas by injection. They inject the ozone gas in the water to kill all bacteria and germs. So if you put a leaf of the planet like this, plants like this, and composed with the exposed with the tropospheric ozone. It will be like this. It kills the tissue in this plants. So now the ozone hole consequences. There is a lot of consequences of the ozone hole. We know the ozone is the ozone hole. Okay, it is not. It is a general. Event or the general problem in the whole planet, but for some areas it is more dangerous, so and not noticeable. So when you go to the polar areas, the North Pole or the South Pole, we can see the ozone hole is very clear there, and the density of the ozone is very less comparing with the other areas or other zones of the Earth. So let's imagine if you live in an area or a country with a very less density ozone layer, the UV light can destroy your DNA inside your cells and it causes cancer يعني لا سمح الله طبعا. So it is very harmful and it's very dangerous thing and environmental problem. Okay, so today is 16th of September. So in each year, every year in this day, the same day, it is the day of the treatment or the protocol that designed by United Nations to celebrate the International Day of Preservation of the Ozone Layer. So they signed the protocol in 1987 to prevent all chemicals that can destroy the ozone layer, the tropospheric ozone layer. And starting from that, I think starting from 2000 year, December 19th, 2000, they start celebrating this date. So let's see this video.
35 kilometers above Earth's surface, a gas called ozone surrounds the planet. The ozone layer acts as a barrier between Earth and ultraviolet radiation from the sun. However, pollution has caused the ozone layer to thin, exposing life on Earth to dangerous radiation. Earth's atmosphere is made up of 6 layers. The second layer, called the stratosphere, contains the ozone layer. The ozone layer is made up of a highly reactive molecule called ozone, which contains 3 oxygen atoms. Ozone is a trace gas in the atmosphere. There are only about 3 molecules for every 10 million molecules of air. But it does a very important job. The ozone layer acts as Earth's sunscreen, absorbing about 98% of damaging ultraviolet or UV light. But the ozone layer has gotten thinner.
If you allow me to stop this video here and repeat it slowly, so you can see the ozone destruction is everywhere, over all cities in all countries. But because of the circular air due to the rotation of the Earth, we can see the ozone hole. It collect or just stay here in this area above the polar area, especially above the Antarctica, by the way.
But the ozone layer has gotten thinner. Chemicals called chlorofluorocarbons, or CFCs, are the primary culprits in ozone layer breakdown. A CFC is a molecule that contains the elements carbon, chlorine, and fluorine. CFCs are mostly found in refrigerants, aerosols, and plastic products. When CFCs are exposed to ultraviolet rays in the atmosphere, they break down into substances that include chlorine. The chlorine reacts with the oxygen atoms in ozone and rips apart the ozone molecule. Areas of damage in the ozone layer are often called ozone holes, but that name is misleading. Ozone layer damage is more like a thin patch, with the thinnest areas near the poles. The ozone layer above the Antarctic in particular has been impacted by pollution since the mid-1980s. There, the region's low temperatures speed up the conversion of CFCs to ozone-damaging chlorine. About 90% of CFCs currently in the atmosphere were emitted by industrialized countries in the Northern Hemisphere. In 1989, the Montreal Protocol banned the production of ozone-depleting substances. Since then, the amount of chlorine and other ozone-depleting elements in the atmosphere have been falling. Scientists estimate that chlorine levels will return to their natural state in about 50 years. By then, the Antarctic ozone hole will shrink to smaller than 8 million square miles.
This is good news. So hopefully this is an example for the international cooperation to solve the environmental problems and the catastrophic events. So hopefully they will do the same for the global warming. We reached to the end of our short presentation today, and thank you to join us. And I think Professor Elias has a comments.
Thank you very much, Rehan, for the nice presentation. So it was concise and very, very informative, and hopefully all of you have benefited. So if you have any questions, so you can ask it openly, or you can chat with us. So we'll be more than glad to answer your question. Please take your time, and please, if you have any question, let us know.
I have a comment, Doctor, about my point here. The first point, it was if there is any relation between the ozone layer depletion and the global warming. After searching some of the papers and research, I found that there is an effect of the ozone layer depletion on the global warming. It is one of the minor factors of that cause the global warming, but it's very, very minor because of the reaching the UV C type ray to the troposphere. It gives we know that the UV photons is very powerful and has a more energy than visible light photons. So it gives some of that momentum and energy to the atmospheric or tropospheric molecules and increase its temperature. But it is very, very minor. It has a minor. One of the factors is a ozone layer, but it is minor. So this is my point that I put it in the first of this the presentation.
Thank you very much, Rehan. So ozone depletion, ozone hole is due because of the use of the CFCs, and global warming is mainly related to what you call greenhouse effect gases data produced, and so on. So please, any question, any comment from the audience?
Yes, Assalamu alaikum, Muhammad.
So,
Please.
My colleague, this is Muhammad Hani. Yes, coronavirus lockdown maybe helped the environment to to ameliorate the ozone layer. Do you think that? Because we have a lot of articles now written by specialists say that we have to stay at home to keep save our ozone layer. What do you think?
yes, it happened last year in 2020 during the COVID-19 pandemic, when they locked down all airports and some of and the traffic also reduced to the minimum. It is one of the it doesn't happen maybe for decades. Yes, sure. Some of the observers they reported that the atmospheric or the pollution rates has or recover. There is a recovering on the air quality. But when you look to the time scale of this lockdown, or we don't know, we don't want to return to these days, but it was a very short period, so it cannot make a massive effect on the reduction of the harmful gases. But the most important thing is the international cooperation for and make protocols to protect the atmosphere from the CFCs or all gases and materials and chemicals that could destroy or it is a harmful gases or poisons for the human being or animals and plants.
Just to add a little bit to that, you may know that the ozone hole depletion is a very hard problem to understand scientifically. You may have seen some of the slides of Rayhan. He was showing the ozone hole, sometimes large, sometimes like it does grow, then it will shrink and so on. Why? Because the air circulation around Earth as it does rotate is very difficult to model. That's why the problem of the ozone has been since more than 50 years. People are aware of it. So some very industrial countries are reducing the use of the CFCs, but still it does grow and it shrink. So we may be aware, as you saw in that video, maybe safe maybe about in 10, 20, 30, 40 years, but it all depends upon how we on planet Earth, how we're using the CFCs that do destroy the ozone molecule. Also, one point here, it has also been stressed by Rayhan also in the video, the ozone hole is the hole above your head. No. It is like a lack of density of the O3 over a given region. It is not only on the South Pole, it is all over Earth. Why South Pole? Because especially during November, December, and January, part of the world is a little bit turbulent. That's why all of these CFCs and so on, so they would get around that region. That's why those people near Australia and New Zealand, they have seen a very high rise in skin cancer. It is a real problem, so we need to take care of it. Okay, so thank you very much for all who have attended. So I appreciate your attendance and appreciate your questions, and hopefully we can give you more and more very informative lectures. The main purpose of these lectures is to inform, and they would like to be as general as possible. We are not going to present any physical equations, any mathematical equations, so just talk about some general concepts that do concern us, and hopefully this weekend I will share with you the new program for all of our activities for 2021-22. I apologize for some of you. I have changed the date because there were some conflicts. First come, first served. You may have chosen date, but someone chose it before you. So hopefully you will understand that. Okay, so thank you very much, Rahan, again. And thank you for the audience, and see you next time, inshallah. Assalamu alaikum.